Today what we're going to do is continue our discussion on partial fractions, but we'll be talking about how to handle what's called a repeated factor. So this is section 7.3, and it's called partial fraction decomposition. But today we're going to be talking about, like I said, how to handle repeated factors. So what a repeated factor means is something like this. Like if you have, say you had something on top, like let's say it was ax, or say it was like 2x plus 1 over x to the third. And you wanted to break this up into separate fractions, decompose it to separate fractions. What you would do is you would have, you see how it's x to the third? You would need something to cover each of those powers. So like just x, then you would need an x to the second, and then you would need an x to the third. That's how that would work. All right. So let's go ahead and get into this. By the way, we would use A for this, B for this, and C for this. So just because we always look at the original factor to determine what the numerical, if it's ax plus b or something like that. So let's take a look at an example. Just to write out what I just said, you must include separate iterations of each repeated factor. When we talk about iterations, that's like x to the first, x to the second, and x to the third. That's what an iteration means. And let's start with an example. What if we had 2x minus 3 over x minus 1 to the second power? Now in the previous lesson we talked about distinct. Like if it was just x minus 1 here, that would be called distinct. But because it's x minus 1 to the second, we're going to have a fraction where it's x minus 1, and we're going to need another fraction where it's x minus 1 to the second power. You start with the first, and then you work your way up to the actual power. The numerator is going to be based on x minus 1. So x minus 1 is linear, 1 degree lower would just be a constant, and same thing with this. Now we're going to solve this just like we've done other problems, where we figure out what the LCD is, and we'll multiply everything by the LCD. Now, in order to combine these fractions, x minus 1 to the second power, of course, is really just x minus 1 times x minus 1. So our LCD is going to need one factor of x minus 1, but it'll need another factor of x minus 1 also. So let's go ahead and multiply every fraction by that, and we'll solve for a and b. So if we multiply it, we'll get, I'll show you all the steps here. X minus 1 to the second times 2x minus 3 over x minus 1 to the second is equal to x minus 1 to the second times a over x minus 1 plus x minus 1 to the second times b over x minus 1 to the second. These cancel, and we get 2x minus 3. One of these cancels with one of these factors, and we just have a times x minus 1. And then we're going to cancel these, and we're just going to get b by itself. So we talked about a couple different ways to solve these kind of problems. One way to solve them was to pick values for x and then plug in. And I told you that works most of the time, especially with like the first kind of problems we saw in the last lesson. But if you want to get the right answer all the time, you want to go about making the equation equal to each other and maybe making a system. So that's the way going forward, that's what we're going to do. What I mean by that is this. Let's distribute the a. So this will be ax minus a plus b. So the total number of x's has to equal the total number of x's, which means that a would equal 2. The total constant term has to equal the total constant terms. So negative 3 would equal negative a plus b. And if a is 2, we get that b would equal negative 1. So as far as what the answer to the question would be, if we were going to decompose the original problem, 2x minus 3 over x minus 1 squared, correct decomposition would be 2 over x minus 1 plus negative 1 over x minus 1 squared. Or you could write 2 over x minus 1 minus 1 over x minus 1 squared. So that's how you do a problem like this. A couple more examples. Second example, what if we had 7x squared minus 17x plus 38 divided by x plus 6 times x minus 1 to the second power. Now we're going to need a fraction for the x plus 6 factor, but the x minus 1 is repeated, so we're going to need one denominator where it's just x minus 1 to the first, and we're going to need a second fraction where it's x minus 1 to the second power. That'll take care of the repeated factor. On top, the denominator is linear, and we're just looking at the x minus 1 to determine that the top would be c. So we'll multiply everything by the least common denominator, which would be x plus 6 times x minus 1 squared. And I'm just going to save a little bit of time. We've been doing this for a while now, and I'm just going to do that in my head. So if we multiply by the LCD here, we would get 7x squared minus 17x plus 38 is equal to a, the x plus 6's would cancel, and you'd have x minus 1 squared, plus b times x plus 6. One of the x minus 1's would cancel, and then you'd have plus c times x plus 6. All right, so now we're going to have a lot of distributing to do, but that's the way that it works here. This will be a times x squared minus 2x plus 1 plus b times x squared plus 6x minus 1x, and then plus cx plus 6c. Alright, so this will be a good time here. We want to group all of the x squared terms together. So we have a and b x squared. We want to group all the x's together. So we'll have negative 2a, 5b, and c x's, and we'll have a minus 6b plus 6c for our constants. And this is going to equal 7x squared minus 17x plus 38. So the way that we could finish this is the total number of x squareds have to be equal. The total number of x's have to be equal. And the constants have to be equal. Alright, so we have a system with three variables. What I'm going to do is eliminate the c's here, and then I'll have an equation with a and b from the top, and I'll have an equation with a and b in the bottom. So let's see what we could do here. If we multiply the top by -6, we get 12a minus 30b minus 6c is equal to -17 times -6 is 102. And we're adding that with a minus 6b plus 6c is equal to 38, giving us 13a minus 36b is equal to 140. And we'll combine that with the a plus b equals 7. Now to eliminate here, we could multiply the bottom by -13, and we get 13a minus 36b is equal to 140, and on the bottom it's -13a minus 13b is equal to 7 times -13 is -91, and we get -49b is equal to 140 minus 91 is 49. So b would be -1. If b is -1, we get that a would be 8. And if we plug both into one of the originals, you'd get that c is equal to 4. So as far as what the answer for this would be, you would write the answer out like this. You would say that 7x squared minus 17x plus 38 over x plus 6 times x minus 1 squared is equal to a plus b and then plus c. That would be the decomposition. If you got a common denominator and added them together, you'd get the original. Alright, so one last problem. What if it was like this? 3x to the third plus 7x minus 4 over x squared plus 2 to the second power. So we have an x squared plus 2 that's a repeated factor. And remember, the numerator always has to be 1 degree lower. So if it's x squared on the bottom, it has to be x to the first. And the way we get the second one is we always base it off of the factor, right? So we're going to have cx plus d. We'll multiply everything by the least common denominator, which is x squared plus 2 to the second. And let's see what we get. Get 3x to the third plus no x squared plus 7x minus 4 is equal to, let's see, ax plus b times x squared plus 2, and then we'll have just cx plus d. So if we were to FOIL this out, we would have ax to the third plus 2ax plus bx squared plus 2b plus cx plus d. Let's group our similar terms together. So we have ax squared, or I'm sorry, ax to the third. We have bx squared. We have 2a plus cx's. And then we have 2b plus d. And that's going to equal 3x to the third plus 0x squared plus 7x minus 4. A has to be 3. B has to be 0. And then we're going to have 2a plus cx has to equal 7. And then the constants 2b plus d has to equal -4. All right, well, b was 0, right? So that means that d is -4. And a was 3, so 6 plus c is 7. So c would have to be 1. All right, so as far as what our answer would be, it would be 3x to the third plus 7x minus 4 over x squared plus 2 to the second is equal to a x plus b. B was 0, so we don't have to write that, over x squared plus 2 plus c x plus d over x squared plus 2 to the second. Now this is a pretty cool thing. I mean, think about it. If you got a common denominator here, you would have the same thing. All right. So for homework, what I would like you to do on the attached worksheet, I would please like you to do numbers 3 and 4. Good luck. Have a nice day.